afternoon and welcome to this session on how to adopt the AWS Cloud with an accelerated pace using the AWS Cloud Development Kit. I'm joined here today by my colleague Ivo, and we're going to talk you through a small workshop that's going to teach you how to set up your first enterprise CDK construct development and distribution pipeline, and we'll show you how to set that up, and later on we'll discuss how the construct is built, why we built it this way, why this is necessary for our customers. And then later on, we'll also show you how to consume this building block, basically showing you how to provide building blocks to your development teams so that you can build compliant and secure enterprise applications. This is my colleague Ivo. He's going to introduce himself.
Yeah, so basically I'm working for Oblivion Cloud Control as well. Been there for 3 years, 3.5 nowadays. Also team lead of Sydney. Working for enterprises a lot. Well, our team is mostly specific on pipelines and CI/CD, and that's why we chose this topic to show you guys.
Thanks a lot. Well, Ivo is also the author of the building block that we're using today. I've asked him to collaborate with me to make sure that this building block that we're using at a customer, it's based on a customer use case. And he's going to talk us through that part of the talk. The talk is divided in 3 sections. First, we're going to show you the pipeline and the autonomy of that pipeline. The second talk is the construct itself. That's Ivo's moment of fame. And then the last bit, like I mentioned before, I'll show you an actual implementation of a pipeline that uses the construct. So that's going to be the whole chain from start to end, a platform development team until the development team that uses the centralized building blocks. To start off, like I mentioned, 3 parts. Coincidentally, all the repositories have been split up in 3 parts as well, just to make it easier for you to digest the different sections and take from those parts what you need in your specific use case. Like I mentioned, it's going to be built around CDK. We're using TypeScript as our main language at Oblivion Cloud Control. That being said, during this workshop, I'll also show you why this is so powerful, because we'll not just be exposing the construct in TypeScript, but we'll be sharing it in multiple languages, TypeScript and Python in this case, but any language that the CDK supports would be supported. And I think that in itself is an extremely powerful concept and a very good reason to leverage something like this. So let's begin the workshop essentially. Like I mentioned, the first part is essentially the pipeline that will build and distribute, or the construct itself. So it takes the pipeline consists of multiple components. Firstly, a code commit repository, because obviously as an AWS partner, we're going to solve this AWS natively. Code commit is our baseline. We use code build to build the construct. And then later on, we'll use CodeBuild as well to distribute the packages to Code Artifact, which is a artifact repository service provided to us by Amazon. This pipeline also built in the CDK, obviously, just to keep the topic going. We've built this. We start our project with using Progen. Progen is essentially a repository generator. It's just a quick and simple summary of what it's used for. It does a lot more. But it allows us as a platform team, because that's essentially what we're functioning as right now in this workshop, to provide a consistent way of generating our repositories according to a certain format. Progen is being used more and more throughout the industry to build and generate these repositories. And I'd highly recommend you to check this out after the session. The link will be in the show notes. There are plenty of talks around this, and today is just going to be a Hello World example of usage of Progen, as is the whole setup. But Progen is going to make your lives a lot easier. So I think that's the very important note. Like I said, project is started in CDK. Using Progen, you have one point of truth. It's the Progen RC file. This file is being managed is used to generate all necessary files in your TypeScript project. Think about package.json, tsconfig, etc. Progen comes with a set of defaults, right, which is considered by the Progen team and the community to be the sane defaults. And using those defaults, you can generate and fill a repository. You have the possibility to override these things. That's what the Progen RC file is for. I won't go through every line because I think that's a bit too much. But I think it's very important to show you a few things in here. We have a few important settings on this file. I think the CDK version and Progen version are very important ones, as we'll dive into a bit later. Version pinning around the CDK is exceptionally important. CDK is a bit iffy when it comes to version management. Semver is only used in the notation, not necessarily in the practice behind it. So minor updates might actually break stuff. So it's going to be extremely important for you as a platform team to also maintain those dependencies and make sure that the pinning of the dependencies and everything is in place. That's why it's important to also this file again is making sure that these things stay in line with each other. If you weren't using Progen, this would be a manual exercise. So prior to the release of Progen, and we've done this before without Progen at other customers, all the dependency updates and etc. would be an exceptional, cumbersome task, I would call it, to manually update everything. And now Progen just basically tries to do that before you. Under the hood uses Yarn, but I will stay out of those details for now.
Small question. Do you see this also already implemented in enterprises, the whole Progen? Because you mentioned community-based.
It really depends on depends on at the time the customer started using and implementing constructs. CDK, basically, okay. We have a big enterprise customer that wasn't using Progen because Progen wasn't out yet, or at least not as a proper release yet. Only in a closed beta, I believe, or open beta, but experimental. And now more and more customers are starting to pick it up because it makes a lot of sense, right? The filling, quote unquote, of a repository is something that's manually intensive, whereas this tool takes a lot of that heavy lifting away. And I think that's really it's only a matter of time before parties start using this more. Further diving deeper further into the autonomy of the file, I'll skip a few things. By default, Progen uses GitHub Actions, and what's really great about this is if you use the Hello World example of a CDK construct, it will set up everything for you. The whole Git flow in GitHub Actions will be built for you. All the pipeline files will be generated. So you won't have to think about that even. The construct will be built and distributed to GitHub, to NPM, to PyPy. Will all be done for you. It will be generated for you. But because, of course, we're going to do this with the AWS native solutions, this part of the configuration has been taken away. Right? You'll see that here. It's a subsection that I commented as a GitHub configuration. I removed that just for the to keep things clear, right? It's not necessary. The files can still be generated. It won't do anything because you're hosting it in code commit. But small note here. Earlier this week, there was an update or a breaking change in Progen. This snippet that I'm selecting right now is a workaround. There was a problem with the library, the DOM library. And this fix was provided in the CDK dev Slack as a quick fix to get around these problems with compiling. So I think that's also a really important resource, right? If you're going to dive deeper into the CDK dev Slack is definitely a major pivot, majorly important point if you want to actively use the CDK. You'll be getting a lot of help. You're an active user, I believe, and you're the one that passed me the fix to this problem. So thanks again for saving the demo for today.
Yeah. To hook up on that. The CDK dev has examples, has questions, but also on multiple levels of CDK. You have CDK Terraform and other things. There have sub-channels on that as well. On Progen, on pipelines, you can ask them everything, and it's a really good community. Yeah.
So to dive a bit deeper into the actual AWS resources that make this whole chain complete, I'm going to dive straight into the source directory where there's a file called pipeline stack. Again, Progen generates these directory structures for you. The main.ts in the CDK is just the definition of your CDK application. So I'm going to skip this, not very interesting, I think. One main important thing, make sure that you tag your resources, everyone. It's best practice to make sure that at least it's clear who owns the resource. It's going to be important for cost management. And I think this is also good to keep a trail of responsibility almost. Because if I'm not going to clean up my stuff later, at least people will know how to pick me and send me a message to clean up my stuff. Diving into the pipeline stack. Like I mentioned, the whole chain consists purely of the pipeline stack itself. Consists of code commit as a base point, a code build job as the thing that builds the construct and distributes it to a code artifact repository for npm and PyPy. That's what we're going to be talking through right now.
One question. You mentioned earlier Progen uses Yarn. Normally, when you install packages, you first have to install, for example, npm install AWS CDK IAM.
Mm-hmm.
That's now being taken care by the Progen RC, right?
Correct.
So
I'll go back to the previous file. Good question. Thank you. There's a list here of CDK dependencies that you define in the Progen RC file. When you run Progen build, which is essentially just a compilation of your CDK app, it will Yarn will install and manage the dependencies for you.
So you don't have to do that manually anymore.
Yes, you don't have to do that manually anymore, which is quite interesting. I would recommend to install Progen on a global level, however, because otherwise you're going to have troubles like as we say it in Dutch, a chicken egg problem, where you need to install Progen, but if you need Yarn to install Progen, it's gonna cost you some headaches. And I think because we're using Progen across so many different projects for so many different customers, this is one of the few things, just like the CDK, in my opinion, that I'm allowed to install globally. Going to this specific CDK app, like I mentioned, we're building a code artifact repository. Before we deploy a repository, we have to create a domain. As for today, I created a Club Cloud domain, of course, to honor this week. In that domain, we'll create several repositories, one for npm, one for PyPy, because we want to separate those. I'll get to that in a second. And what I want to show today in this bit is that we're hosting the repository on one account, a centralized account for the cloud platform team, for example, in which we'll be hosting and storing those artifacts. But any entity or any account in our organization will be able to retrieve these packages from that repository. We do that using a permission policy document specifying all the required activities. I think I have two statements in here. A statement that allows the read and getting an authorization token so that you can in fact get the package. And then also having write access to this domain. So we're setting these policies on the domain level from this account only. So the account that hosts the domain and the repositories. That being said, if you want to do this on a larger scale and you want teams to contribute as well with their own constructs, this policy will not be sufficient. Like I mentioned, the right is limited to only the cloud platform team's AWS account. If you want to do this on a more scalable solution, a more mature one, in my opinion, the ideal solution, you're going to have to tweak this policy a bit to allow teams to write in their own repositories, for example.
Yeah, and then you would deploy it to a, for example, shared services account or something.
Yes, you could still host it in a cloud platform team's account. I think that it doesn't really matter where this is because we're using the AWS APIs to store and to push and to pull. So it doesn't really matter where it is. It's just that you want to make a bit more complex, I would say, structure and chaining of repositories to make sure that teams can only write to their own respective parts of the whole domain and the repositories within that domain. Like I mentioned, within the domain, the Club Cloud domain, we create two different repositories, the npm one and the PyPy one. We do this right now in this Hello World example to make sure that we can set external connections. And for an external connection for an artifact repository is, for example, a public npm, What that allows us to do is give the development team access to our repository, the one that we host as a cloud platform team. They log into that repository, they get their authorization token like I mentioned before, and they can get all their dependencies from that repository. And we get them from the internet. So it's basically, I would call it a proxy almost. Yeah. That gives us the possibility to make sure that the team doesn't necessarily get everything from the internet. It allows us to control what's coming in, what's coming out. We can, so there's a lot of control there, and I think having that layer in between that's controlled by a central team effectively increases your security, so that we just don't get random packages from all over the internet, maybe with vulnerabilities, because there are plenty of them, and we have the ability to limit what comes in and what goes out. We made the separation here because we can only have one external connection per repository. So if we want to have the npm upstream, we need a separate repository from the Python one, because we want the upstream there as well. Again, code commit repository. This is going to be the source of truth for our code pipeline. It's always a great tongue twister. That's going to eventually make sure that our object arrives in code artifact, the repositories that I just showed. Within code pipeline needs a role. I've been lazy for this talk. I'm using a role that's being used by both code pipeline and code build, and uses administrator access and manage policy. Terrible example. Don't try this at home, and definitely don't use this in a real environment. This is just for demo purposes. This requires more tweaking for sure. Don't use this. I think an important note, because we're going to hopefully be building a lot of these constructs over the future as a team, we're going to use a image that's available from JSII, which is the transpiler used to translate our TypeScript construct code into TypeScript, Python, whatever language is supported. But because Docker Hub has recently been limiting the pulls you can do from Docker Hub on a single IP address, it's important to make sure that you is that the correct word? Inner source? Yeah. It's important that you store the image from JSII in your own repository. We chose to use ECR. We have that centrally located. It's not part of this chain because we already have it and we needed it for other purposes, obviously. So that's what you're seeing here in the build image. This build image will be used across the whole pipeline and all code build steps. Going into code build, I think this is obviously the mandatory part in order to build and release your construct. The contents of this build spec have actually been taken from Progen. So like I mentioned before, if you leave up the GitHub configuration in your Progen file, it will generate all the workflows for you with the GitHub Actions file. The contents of this build spec are actually from there. We've made some changes because things are working differently in GitHub Actions as they are in code build. I'll get to that in a second because we're missing some stuff. But in general, the steps involved in here are just taken from what's been given to us by the Progen team, basically. A few things here. I've made some. I've obfuscated some of the values for security purposes, I would call it, like our organization ID. We're not supposed to show that, obviously, on stream. So that's why we have some environment variables and parameter store values stored out across the board. You'll have to set these prior to if you want to follow through the GitHub repository in the README. And the exports and the parameters that need to be in place will be included in the README as well. Going into the npm publish task. The pipeline essentially, I'll pull this up. We've already deployed this whole thing, of course, just to save us some time during the demo. Our pipeline consists of a few steps. Sorry. We have a code commit source, like I mentioned. There is a release build step, is what I call it, which is essentially where we build the construct once and then we release it many times, right? We want to make sure that that we have essentially one truth. If we were to build it in every publish step separately, depending on how you do your dependency management and the underlying OS, there could be a difference. So that's why we've chosen to make sure that we build it once and then publish it many times. So again, the release build is the build part of it. The output of that step is being forwarded to the publish steps, and in the publish steps we use that to eventually publish to npm and to PyPy. going back to my editor. This part is essentially just usage of code artifact and npm to publish the package. It's nothing spectacular. It refers, as you can see here, it refers to the code artifact domain mentioned before. It uses the repository for the npm repository that was mentioned before, as you can see here, and it's just a predefined URL, so we can basically string substitute it with based on the values that are derived from the resources mentioned before. And we have to set up the npm configuration correctly, because part of this image is the is Yarn, of course. Yarn is going to manage the dependencies, but the publish still happens through npm. And in order to publish, we need to set the npm RC properly, and you can see that here. As you can see here, we're outputting these files, these configuration lines to the npm RC file. As a last step, we're using JSII release to release it to code artifact, in this case the npm one, and you won't be I'd like to think that it's not going to be a surprise that we're going to do a similar thing for PyPy. This is a lot shorter. These steps are also just coming from the AWS documentation, with some tweaks, of course, because those have hard-coded values. We want to make sure that it looks all shiny, so we used string substitution for this. I think one important note, and I was discussing this with Eva this morning, and I mentioned this before, version management is very important here. What's difficult in using code build right now is using Git information to make sure that we have the correct tagging, we have the correct logs available, and by default, if you pass code build to code commit to code build, that information is lost. You have to make some changes to that to do that, and I'll show that in a bit at the bottom of this part. But JSII uses that Git information in order to make sure that the tagging happens correctly for the constructs that are pushed to the artifact repositories, which is important, because the information is not there, you're going to have to make something for that yourself. That's not part of this talk. It's the version handling is not done in here. JSII is always going to release it as latest. Ideally, you want to make sure that the Git tag comes through, and you're going to have to make something for that yourself in order to fetch the Git tag as part of this pipeline. Again, not included right now. Going to the code build code pipeline. Nothing spectacular here. Like I said, code commit source, code build to build the artifact, and then release it to code build. The last part here, and there's a to-do. We use the CDK escape hatch, and I'll leave a link in the comments to what an escape hatch is. But sometimes the CDK layer 2 constructs don't have the possibility to change certain settings. One of the things that we want to change in here, like I mentioned before, code commit doesn't pass the Git information to code build. By setting a certain CloudFormation parameter, the output artifact format of the CFN of the CloudFormation code of the code pipeline, we have to set the output artifact format to a certain value, the code build clone ref. This makes sure that the Git information comes through, and I think that's going to be without this, the pipeline won't work at all.
Yeah, basically under the hood, what it does, it picks also the .git directory, yes. Right?
Yeah. So normally, if you don't set this, it just zips the content of a Git repository, and now it also zips the metadata with the artifact, which is necessary for this to even remotely work. It's still missing some data, which is unfortunate, so you have to build around that, like I mentioned. But this has to be set, and like I mentioned, this setting can't be managed from CDK itself. So we use an escape hatch, which essentially taps into the generated CloudFormation resource under the hood and replaces that value. For this, that's it, right? When we deploy this, the pipeline is there. As you saw, as you might have seen before, we've already had some successful runs, of course, to prepare for this talk. Normally, your first deployment of this project will result in a failed run, right? There's nothing in the code commit repository, so it's never going to be able to run or build anything. And we'll move into that second part now. The second part is the construct itself. I think, Ivo, if you can talk a bit about why we need this construct specifically, and the parts that are in this construct, and why it's set up like this and what they do. I'm going to pull up the actual file itself, but I think an introduction as to why this is needed might be nice for the listeners to hear.
Yeah. Maybe you can pull up the README first. So basically, I'm working at the customer. They have a strict CIA rating defined by the security team. And one of those rules are that bucket versioning needs to be enabled, public access needs to be blocked, SSL needs to be enforced, access logging needs to be enabled, and encryption on the bucket must be via KMS, a customer managed key. Because I'm working at a data analytics team, we use a lot of buckets, and you can create the code all the time, but then you're copying constantly large chunks of code. So what I did, I created a construct which you can call and sets the correct bucket permissions for you, and then your code is limited to only one rule instead of the whole 20 lines of code. To do so, normally you would package that and give it to, for example, Code Artifact or any other code artifact store. And that's basically what we are achieving here. And the team now itself can use this construct to have a secure bucket. And if you scroll a bit down, you see how it works. So basically you install, I see the latest README hasn't been pushed, but yeah, you just install the package and then call it via the new secure bucket with the props, and then you have a bucket created. And if you go to the code itself, it's just it's fairly easy. It sets some bucket props. And on the line 26, you see the actual how you normally would create a bucket, new bucket. But you use the props, and the props are, as mentioned in the README, encryption is done by KMS. The public access is to block all, and all those kind of things.
And when it comes to these settings, right, you're providing this to a team. In the context of the talk, right? You use this as a direct implementation at a customer for your team itself, right? To make a reusable thing. In the context of the talk, we want to provide this as a construct for all our teams. And like you mentioned, you need this in order to be compliant with your
security team.
Security team, basically. When I pull this construct in my consumer pipeline, as I would call it, where we use this building block to deploy these buckets, I see this property called version is true. Is it possible for me to override these values?
In the end, you can override it via an aspect file, for example, and that's basically what you've done with your git tag property, so that you generate your CloudFormation template and then do your change. But when just calling the secure bucket construct and you, for example, say version is disabled, your bucket is does still have the versioning enabled. But this is specific for the company where this security policy is needed. And for other companies might have that KMS S3 key is sufficient instead of a customer managed key.
So there's a few things that I wanna address here or ask you about, because you said something about an aspect. What is that?
So with the aspect, you can override certain CloudFormation rules, like what you did for the Git property. You override your CloudFormation configuration, and for example, you can say the version true here on line 19 results in a CloudFormation temp rule or property, I must say, and with an aspect you can override that property, and now it's saying true, but then you can say that it's false.
Yeah, okay. So would you say then that
you must see it as a hack. But this construct is created to make it the life of the developers easier. That with just calling the secure bucket construct, they have a secure bucket created and compliant for security. If you're going to hack that, then you're not compliant anymore. So
So you could argue that a detective control still needs to be in place to validate whether these properties are still being set. Okay, thank you. So I think this bucket construct is now here, right? As you say, you explained the autonomy of it. We've pushed this construct to code commit, as you've shown in the previous pipeline run, but I'll walk through that in a second. I'll show the code commit repository. This construct will eventually become available in Code Artifact, like I mentioned. So I think it's time we start using it, consuming it, and show the strength of this. Also showing how the defaults work, and of course, without the hacky workaround like the escape hatch or the aspect, like you mentioned, that we just get a secure bucket as described by your construct. I think that would be the next step. So we've talked about the pipeline itself. We talked about the construct itself, and I think
normally you would check this inside the code commit repository of your pipeline, right?
Yes, you normally you would include this, right? But like you said, it's going to be a lot of copy pasting if you don't store this construct centrally.
Yeah, but building your construct, this repository is used in your pipeline to build the construct.
Yes, correct. Yeah. So I'll go quickly into the construct construct directory to show you and the viewers that it's already been pushed to code commit, right? The remote here is the code commit repository that we created in the first stack that we displayed
for the pipeline.
Yes, in this part. So like I mentioned, we'll dive into the consumer part right now. The consumer part is essentially just a simulation of a application team that is using CDK pipelines, because that's the coolest way to use CDK nowadays, to build their application. Their application happens to only consist of an S3 bucket, which is very plain, but for the demo purposes, we didn't want to make it too complex. So we'll show how that repository again is set up, again using Progen, but it's a different setup. So that's important to show, I think. And then also using CDK pipelines to make an application stage, which is a development account, and then using that application stage to call the secured bucket construct multiple times with different configuration, and then showing the effectuated outcome of it. And I think that's going to be a good thing to show to our viewers. So the Club Cloud pipeline repository is essentially sorry, this is the wrong repository. The
consumer.
I have to go to the consumer. The consumer repository is essentially what makes the whole chain complete, right? So we had the pipeline that the repository that creates the pipeline and all the components in that pipeline. We have a repository that just is nothing more than just construct code that is being pushed to the things that has been created by the first pipeline, and then the last part is the consumer of it, and that's what we're going to talk through right now. Going through this, let's talk about the Progen RC file quickly. Very simple. An important thing to note here is the new style synthesis. This is required for CDK pipelines. I'll also include a blog post by AWS on how to use this. It's really cool. It's almost like a prescribed method, you could argue, with how to use CDK in a dynamic model. And it's honestly, in 9 out of 10 cases, CDK pipeline works perfectly fine for the end goals that we have. So I highly recommend looking into CDK pipelines. I really aggressively use it wherever I can. The only time I don't really use it at this point is when a customer has a CI/CD toolkit that does not live inside AWS, basically, like GitLab or Azure DevOps and all those kind of things. The file in here looks very similar. The only thing that is worth mentioning here is that this is a Progen app project of the TypeScript app The
Yeah.
previous one was a TypeScript construct. The files that are generated as part of this Progen project are different because of it, right? The whole repository looks slightly different. That's, I think, the most important to note. When you use Progen, you're going to have to pick one of the many projects you can generate as a default. So this is an important distinction. Going in here, like I mentioned, the main stack is always going to be the entry point for your application. From there, using CDK pipelines, we create a pipeline stack, and that pipeline stack eventually starts creating CloudFormation stacks. The pipeline stack, again, as with many of these CI/CD stacks that we host in AWS, starts with code commit. Then there are a few steps. In this case, there's a code build step that basically generates your CloudFormation files from your CDK app using the construct created in the other repository. And then there's a CloudFormation deploy step that takes those files, those synthesized files from the CDK, and deploys them using the code pipeline integration for CloudFormation. Again, code commit repository, I think, is very simple. I think the synth action is the real breaking point here. Because we're hosting our packages internally, we need to make sure that our pipeline, during the synthesize step, which generates the CloudFormation stacks for us, gets those from the code artifact repository that's hosted inside our central account, right? So we need to make sure that as part of the synthesize step, our pipeline fetches an authorization token so that it can pull the NPM packages, not just the private NPM packages that we built as part of the previous pipeline, but also the ones that are required as part of the dependency chain. AWS IAM is an example, or AWS KMS is a dependency for this project, and we need to get those from the upstream NPM, the public NPM. That's why we set up this external connection that I mentioned earlier during the talk. So this step here, the install command, is essential, right? If we don't do this, we're not going to be able to find the private package. We'll be able to fetch the public packages, right? Because this code build job is internet connected. This is not going to happen in an enterprise, ideally. Your code build jobs are going to be isolated inside of VPC, and egress traffic will be monitored or restricted. So you're going to have to make sure that it logs in. By default, the CDK pipelines build command and the synth command are native CDK. Progen uses different commands. Under the hood does a lot of stuff similar to the native CDK commands, but this is why there's a change in terms of the value that we input. Here you can see that we call Progen to build and to synthesize. Normally this would be a CDK build or a CDK synth, but Progen does a lot of things under the hood for us, like the yarn dependency management. This part of the pipeline needs, again, to fetch the authorization token. We allow that on a domain level, as we showed at the start of the talk. But also, of course, this pipeline also needs to have the permissions to perform that API call. This is what we're doing here. We're allowing it to get an authorization token for code artifact. And here we need to get a token for the service itself, for code artifact, because it does some stuff under the hood to make sure that we can fetch the artifact for us for this pipeline. Now there's an application stage. This is the dev stage. It's just a dev account. Like I said before, we've hidden some of the account IDs just in environment variables. In the real world, you would either hard code them, especially in an application stage, hard coding the account IDs is not uncommon. And as the end part of this would be using a CDK output just to get the code commit repository URL, so that we can later push this app again to the same code commit repository. Because that's a bit of an iffy thing with CDK pipelines. You first set up the pipeline from your command line. You have to perform an actual Progen deploy to build the whole chain for your consumer application. And once that is in place, you add the code commit repository as your remote from your CLI, and then you push the stuff to it. From that moment on, you should be disciplined and only use that code commit repository to manage the whole chain. Now, to get into the actual application, it's going to be very simple. All it does is call the S3 construct stack. Well, this is very simple. And in that construct stack, we call Evo's construct, right? We use the secure bucket construct that we created earlier down the chain. Or up the chain, as you could call it. And we call it twice here. We call it twice because I want to demonstrate that we have a property called version. As Evo's construct and his explanation showed, this is a default setting. It needs to be enabled as per the company policies, and we want to override it because I'm a bad developer. I don't like versioning, and I think it's overrated. So that's why I want to set it to false, right? And when we set it to false, Evo's defaults on the construct will override this. And I think that's a really powerful thing to show. Like Evo said, we can still get around this, and that's why we have detective controls. So using construct does not take away the necessity of using detective controls to validate whether our resources are configured compliant using AWS config or something similar. But it still needs to be in place. We can't rely solely on the construct itself. What you could do, and don't recommend it, but you could also build our aspects into the construct. But if a team would then layer an aspect over that, it will start creating, let's say, a conflict of interest.
Yeah.
So this still relies on the trust you have with your development teams to use these constructs and depend on them almost, or use these as their same defaults. Again, Evo has exposed some parameters and also made sure that some parameters are simply not changeable. So when we deploy this, and I'll show you that in the console for a bit. Let me switch to the correct account. In this code pipeline, in the, again, code commit source, that takes our code commit repository, zips it, this time without the information, the get information, because we don't necessarily need that in CDK pipelines. We take that, we build that using the CDK send, or actually Progen send, and I'll quickly dive into this here and go into the entire log. Hope it's readable. Let me give that a second to wrap up, to round off. That's not going to be very readable. So you're going to have to trust me on this. The pipeline logs into the repository, gets it from there. And I think actually, I think it's a good idea to go back one step into the artifact repository to show you that we actually have the resource in there. So.
Yeah, which is created by your pipeline.
Yes,
right?
Yeah, I think that's a really important one to make sure that it's there. So going into here, secure bucket. This is actually an important note to make. Earlier during the preparations for this talk, we named it as a secure bucket, but because we're connected to the upstream, Code Artifact would fetch the upstream secure bucket construct. So make sure that when you put artifacts in here, that they're named in a unique namespace, I would call it. I'm not sure if namespace is the correct word as part of the NPM terminology.
Yeah, so basically what you're saying, someone else created a secure bucket.
Public secure bucket.
And pushed it to NPM.
Yes, took a bit to figure that out, but so we made sure to prefix it with the ad platform in this case to make sure that it's at least... But you need to make sure that this is in place, because if you don't, you're going to have a bad time. So naming convention is going to be very important in making sure that the objects are distributed properly. So going back to the code pipeline to wrap things up, the consumer app, again, we have a build that synthesizes, gets the packages from our code artifact repository, generates CloudFormation templates from that, and eventually deploys them. I'm going to skip the update pipeline step, but basically this is the dynamic aspect of CDK pipelines. If you were to add a stage, the pipeline updates itself, which is quite nifty. I don't think a lot of pipeline tooling does that, so I think that's pretty cool. I won't dive into too much detail, but here, as I showed before, there's a dev environment application stage, and in this we deploy these CloudFormation stacks, or actually one stack. So to show how that looks in the real world as a CloudFormation stack that comes from this whole dependency chain. This is the stack that has multiple resources. I hope the zoom level is doable. I'm going to look for an S3 bucket. We're going to have two, of course. I'm going to open them both because we created two. We created a test bucket and we created my bucket. I'll quickly show that here. My bucket and test bucket. Obviously, like I mentioned, with different configuration. Now, if all goes well, we're going to look at the properties of that bucket, and we're going to see for the my bucket, in which we didn't specify any versioning configuration, the default would be enabled bucket versioning.
Yeah,
Let me
there it
zoom
is.
in a bit.
Yeah.
You can see that here, enabled bucket versioning. And as we'd like to think, and I'm going to show that as well, of course, this bucket, even though that we set versioning to false, right? We don't want it to be versioned. it's still going to enable versioning for us, because that's the functionality that our construct provides. And I think that's a nice wrap up around the doc for today. We showed how to build your construct using AWS native tools, how to distribute them. You're going to have to do some work when it comes to the tagging around it. You're going to get flow around that, right? It doesn't come out of the box, the functionality from AWS. So you're going to have to engineer some stuff around that. We'll make sure to include resources for that. So again, we build, we distribute, and then later on we consume. And I think we showed today that's fairly simple to get started with this, to build a construct like Ivo did for his team, to enable teams to quickly adopt AWS using best practices and security requirements without having to do all the heavy lifting themselves, and making sure that the platform team is the team with the knowledge to provide these fairly low, it's the platform that provides these constructs so that they can be used quite quickly into the enterprise application development, so you don't have to do all the heavy lifting yourself. I'd like to thank you, Ivo, for joining me on this talk, and thanks for providing the inputs. Next Friday, we'll be getting back to deep dive into questions that you've been asking today in the chat. We'll be talking about these questions. We'll be diving deeper into some of the caveats that we run into when doing this, maybe the versioning and whatnot. So I'd like to invite you to send as many questions as you can with regards to this talk, and see if we can, Ivo and I can tackle them. Stein is also going to be joining us as a former security officer, I would call it, to ask us the difficult questions about how to make sure that teams are going to adopt this properly and stay within the boundaries of the organization. Thank you. Thank you, Ivo.
Thanks.